Hi, you're welcome back to Quiver Analytics, and in this video we will be testing for we'll continue our discourse on experimental design, and here we want to look at one-way and two-way ANOVA in Python. All right, so the one-way ANOVA. The part one is dedicated to one-way ANOVA, and what we want to check is the age group effect on outcomes. And our outcome is reducing anxiety using play therapy. So, um, does age group affect how effective uh anxiety is reduced among patients? Does age group of nurses affect them? Say that the older the nurses, the more effective they become, or the younger the nurses, the more effective they are. All right. So, for to perform a one-way ANOVA, you must have a categorical variable and a continuous variable, a measurement variable. So in this case, the categorical variable is the age group, and then the age group must have, the categorical variable must have at least three factors. It must have at least three factors or three levels. So for example, the age limit, we'll see that later. So we should have something like 18 to 21, maybe 18 to 21, 22 to 25, 26 to 30, and so on. So the levels must be more than 2. If they are 2, then we'll go back to the independent sample t-tests. Independent sample t-test handles when the when the factor levels are just 2. Once they are more than 2, we bring it to one-way ANOVA. All right, so we load the libraries. It's still loading. It's loaded now. Then we upload the file, the NOSCAP file. Right. So now the ANOVA, the age groups, like I said, we have 18 to 25, 26 to 35, 36 to 45, then 46 and above. All right. So we have one, two, three, four levels, and the play therapy. The reduced anxiety is in values. It's a measurement. All right. It's a continuous data. So here we want to make sure we convert age to categorical data, because in our data it is entered as text. So um, we've done this before, and we just categorize it. All right. So frequency distribution of age groups. So here we want to calculate how is the age groups distributed. So the 20 to 30 years are the most frequent ones, 33, while the 31 and 40 to 40, 14, and so on. So obviously you can see here that we don't have enough 41 to 50 years, and then the above 50 years as well. So this might affect our analysis. In some cases, we might just remove these two, then perform the two, the independent sample t-test on just these two, right? So let's see our charts. So you can see the distribution for the 41 to 50, because they are just one person, and while this one is 2. Okay, 41 to 50 is 2, above 50 is 1. So same thing here as well. All right. So for our one-way ANOVA, we want to plot this one ANOVA for two independent variables. That's the anxiety and then the perception. We want to also check, does age affect the perception of nurses on play therapy, how it reduces how it reduces anxiety among the patients. All right. So we're going to get our test result now. So for reducing anxiety through, I mean, influenced by age, we have a statistic, a significant, oh, not significant, because it is 0.6, while for the other one is also not significant, 0.7. So the interpretation is that this means there is no statistical difference in anxiety reduction across different age groups. So it means that the age across the age groups, within each of the age groups, there is there's no difference between them. This does not mean that the is not effective. It just means that whatever is happening in the 21 to 30 um, age group is not different from what is happening in the 31 to 40 age group and in the other age groups too. All right, so perception is saying the same thing, that there's no difference in whatever is happening in across each age groups. All right, so now for the two-way ANOVA, we're looking at two-way ANOVA. This time around we have age, and then we have duration of how long a person have spent um, on that career as a pediatric nurse. All right, so this time around we have two categories, not just one. We are using age, which we've used before, and now we are adding another time factor, which is um, how long they have spent on the job, also a categorical variable. All right, so we are going to see both of them now. Here again, we are categorizing both variables, those text variables, the age and the work tenure. All right, so let's see, yeah, cross tab to see. So we have work tenure 1 to 2 years, age 20 to 30 years. It means that how many people are between 20 to 30 years who have 1 or 2 years experience. There are 20 of them, and so on. Now notice for how in 41 to 50 no one is in this age group, no one is in this age group, no one is here, no one is here. So it means our ANOVA problem is going to be having a little bit problem. All right, okay, so because it's not complete, there are some groups that have nothing. So we run the ANOVA analysis by just specifying the dependent variable, that's the measurements. It has to come first, while the independent variables age and work tenure comes after. All right, so if you check the ANOVA table, so you can see the error I talked about. So the ANOVA table says that age is not significant, neither is the interaction between age and tenure significant. Of course, it comes lower when both of them are joined together, but it is not significant. All right. So normally, because it's not significant, we're not supposed to do the post hoc test. However, for the sake of practice, let's do the post hoc test. And the post hoc test, assuming this is significant, that's when it makes sense. Assuming any of them or all of them are significant, that's when it makes sense, because it's test, here we are just saying that age, work tenure, and here it's saying age and work tenure. So now you can see 20 to 30 years combined with 1 to 2 years experience. So those between 20 to 30 years that have 1 to 2 years experience, we do not reject the null hypothesis. So it spells it out. It spells it out. The interactions, it spells it out, and gives a remark whether it is significant or not, so that we know what is responsible for the significance in our two-way ANOVA. All right, this can also be done for one-way ANOVA as well. Right, so given this, in the next video we'll move to correlations and regression. All right, thank you for your time.